All right, so this is just a continuation from the last video over section 2.2. We're finding derivative of the following, like we just did an example in the last video, was number 17. And then I showed two ways to do it. Like the first way was going literally step by step. And then the second way, same thing. It's just I'm skipping some steps and doing it a lot quicker. So for these, this next one's similar to the one I did at the end of that video, and I'll do it step by step and then show the quicker way, skipping some steps, how I would do it. And then for the remaining ones, I'm going to do it using the quicker way. So for number 21, says s of t equal to t cubed plus 5t squared minus 3t plus 8. And so what I would do, hold on a second. So the derivative s prime of t is going to be the derivative of each component. So I'll do it again step by step at first, and then do it the problem over again, but skipping some steps instead of having to write the d dt notation. So I'm going to take the derivative of each component. And the last component, or the last term, is 8. All right, so I attach this d dt notation to each term, and that's using, so that's the notation for derivative, and the derivative is an operator. So I'm operating on t cubed, operating on 5t squared, operating on negative 3t, and then operating on 8. And so I'll be using the rules. And so from the last video, if I were going to take the derivative of t cubed, I would use the power rule. And the power rule says I drop down the exponent, so drop down 3, and then you t raised to the, and then you subtract 1 from the exponent, 3 minus 1. All right, that's power rule. All right, so that's the power rule. And for the next term, I'm going to first factor out 5, and that's using the constant multiple rule. Which just says you bring out the constant and then find the derivative. So it's c times f prime of x. All right, so that's the constant multiple rule. So I'm going to factor out 5 and then focus on taking the derivative of t squared. All right, the next term, I'm going to apply the same thing. I'm going to factor out negative 3 and then focusing on taking the derivative of just t. Derivative of 8, that's 0 because that's a constant. So the constant rule just says if you take the derivative of a constant, and a constant's just a number without any variable, c, it's going to equal 0. All right, now I'll keep going. So this will be 3t squared. and now it'll be plus 5. And now I take the derivative of t squared. I'm using the power rule on that. And I usually put the result in parentheses. So I drop down the exponent. So it's 2 times t to the 2 minus 1. All right, and then for the next term, I take the derivative of t, and derivative of t is 1. And that's the special case of the power rule. So this will be minus 3 times 1. And then plus 0, you can just go ahead and ignore the 0. So the special case of the power rule, just anytime you have a variable where its exponent's 1, like just taking the derivative of x, you get 1. Taking the derivative of t, you're going to get 1. So that's the special case of the power rule. And you should just have these, after you've done this whole section of examples, hopefully by this point you'll have these rules memorized. All right, so I just keep simplifying. So this will be 3t squared. 5 times 2 is 10, so we plus 10, and then t to the first power, so just t, and then minus 3. And then that's as far as I can go, so that's the derivative. All right, so I applied the power rule, constant multiple rule, constant rule, and the special case of the power rule for this problem. Now I'm going to do the problem over again, but this time I'll do it quicker, and this is how I normally would do it, what I'm about to do. So I'll write the original problem. All right, so I'm taking the derivative, so s prime of t. And then I don't write, me personally, I don't write this part where I do d dt of each part. I just know that I'm taking the derivative of each part, or each term. So if I were to take the derivative of t cubed, that's using the power rule. And the power rule, right, says I drop down the exponent 3, and it'll be 3t to the 3 minus 1. Now for the 5, because it's a constant, I factor it out and then take the derivative of t squared. So I'm going to be plus 5, and then parentheses is the derivative of t squared. And I apply the power rule for the t squared, so I drop down the 2. So it'd be 2t to the 2 minus 1. Now the negative 3 is a constant, so I factor that out. And then focus on derivative of t. Well, derivative of t is 1, because that's the special case of the power rule. And then the last value, plus 8, derivative of that is 0, because that's the constant rule. All right, so I pretty much skipped some steps here, and now I can pretty much have the answer at this stage. If I simplify this, this will be 3t squared, 5 times 2 plus 10t, and then minus 3. All right, that's how I normally will do it. And again, I used power rule. And then the t squared power rule. The derivative of t, that's just 1. That's the special case of the power rule. And then derivative of 8, that's a constant. That was 0. That's the constant rule. that I applied. All right, so from here on, for the remaining examples, I'm going to do it how I did it in this route in purple. All right, so the next one, that was number 21. 23 is taking the derivative of pi over 2 times sine theta. All right, so it has a trig function, sine. And from earlier, in the previous video, the derivative of sine is cosine. And so for this one, it'd be y prime. And then pi over 2 is a constant, so I factor that out. And then focus on taking the derivative of sine. Well, derivative of sine is cosine. So this would be pi over 2 times cosine of theta. And then that's it. That's my answer. Again, the pi over 2 I factored out, and then I focus on taking the derivative of this, and that's cosine of x. All right, the next one, number 25. All right, so derivative, I take the derivative of each term. The derivative of x squared, I use the power rule. So the power rule, I drop down the exponent, so it would be 2 times x, and then you subtract 1 from the exponent value, so 2 minus 1. Now I have this negative 1/2, so I'm going to factor that out, and then focus on taking the derivative of cosine. And derivative of cosine is negative sine. So I'm going to put negative 1/2 and then parentheses what the result is when I take the derivative of cosine, which was negative sine. All right, so y prime, that'll be 2x. Because of a negative times negative, that's going to be plus 1/2 sine x. And that's going to be my answer. All right, the next one is number 41. So before I take the derivative, I'm going to rewrite the function since I have the variable in the denominator. So since t cubed is in the denominator, I'm going to rewrite the function into a format where I can take the derivative. So based on the rules that we've learned so far, I need to rewrite this into a different format. And so the format's going to be, so the first term is still just t squared. But I can rewrite negative 4 divided by t cubed as negative 4t to the negative third power. All right, that's using the exponent rule, or one of the exponent rules. Well, and then this way I can apply the power rule. So we're supposed to know our exponent rules, and anytime you have the variable in the denominator, like 1 over x to the n, that's the same thing as x to the negative n. Now I apply the power rule. So for t squared, applying the power rule, that's going to be 2 times t to the 2 minus 1. Then the negative 4, I factor that out, and then apply the power rule to t to the negative third. So the exponent's negative 3, so I drop that down. And then it'd be negative 3 minus 1. And I should be writing primes. This is g prime of t. So this would be 2t. Negative 4 times negative 3, that's positive 12. And then t to the negative 3 minus 1, that's negative 4 power. So I'm almost there. I just need to rewrite it so that there's no negative exponent for my answer. All right, and that's using the same rule as I applied earlier. All I got to do is put the t in the denominator to make it 12 over t to the fourth. All right, so that's going to be the answer. All right, so that was number 41. Now next one's number 43. All right, now this whole thing, this is a little more complicated than the previous ones we've done. So I'm going to rewrite this into something that I can take the derivative of. So rewrite it. Now, it wouldn't make sense to write it as times x to the negative 2 since you're plotting, well, you could, and that is one way to do it, but if you do write it as x to the negative 2, you have to multiply it to all 3 of the terms. Another way to do it is to break it up into 3 fractions, where the 3 fractions, the first one's x cubed over x squared, then minus 3x squared over x squared, and then plus 4 over x squared, which would be doing the same thing as multiplying it by x to the negative 2 to each term in the numerator. All right, so x cubed over x squared becomes x. So it's f of x is equal to x. The x squares cancel out, so you're just left with minus 3. And then for the 4 over x squared, I would rewrite this so the x squared is no longer in the denominator. And that would change this to be plus 4x to the negative 2. So that way I can apply the power rule. All right, so the derivative of x is 1, right? That's the special case of the power rule. And a derivative of the constant 3, that's 0. So that's the constant rule. This be f prime of x equal to 1. If you want to be detailed about it, I'm going to put this as plus 0 for the negative 3. Then I factor out the 4. and apply the power rule to the x to the negative 2. So I drop down the negative 2, so we negative 2 to the x, and then you subtract 1, negative 2 minus 1. All right, so then just going about simplifying f prime of x. Ignore the 0 now, so it's just 1, and then 4 times negative 2, that's minus 8. And then x, and then negative 2 minus 1, that's negative 3. And so then I'll rewrite it so that there's no negative exponent. And it changes it to be 1 minus 8 divided by x cubed. All right, and that's going to be the answer. So I wrote it so that I'm dividing each term in the numerator by the x squared. You could have multiplied every term in the numerator by x to the negative 2, and you get the same thing. But this is how I did it. I just separated it into 3 fractions, since we have plus and minus between each number in the numerator. And that's how you can do adding and subtracting fractions. Yeah, that's how I did number 43. Now this next one's number 51. So it's 6 square root of x, and then plus 5 cosine x. Now, because there's a square root, we would rewrite this, and we would rewrite it using the rule with radical signs, is that if you have the nth root of x, that's equal to x to the 1 divided by n. So for example, if I have the cube root of x, that's equal to x to the 1/3. Now here I have a square root, and for square root of x, it's equal to x to the 1/2. They don't write the x or the index, like for cube root, 3 is the index. They don't write the index for square root. The index is assumed to be 2. Right, so you could technically write it as this with a 2 for the index, but it's just they don't write it. It's like one of those things where they don't write 1. All right, so that changes the problem. So now I'm going to rewrite the problem. So it's f of x equal to, instead of 6 times square root of x, it'll be 6x to the 1/2 using that rule, and then plus 5 cosine x. And now I take the derivative. So f prime of x, factor out the 6, focusing on x to the 1/2, you use the power rule. So you drop down the exponent to be 1/2 x to the, and subtract 1 from the number, so 1/2 minus 1. All right, then I have plus 5. Factoring that out, focus on taking the derivative of cosine. And the derivative of cosine is negative sine. All right, so what do I have now? So I have f prime of x equal to 6 times 1/2. That's going to be 3. And then x 1/2 minus 1 is negative 1/2. And then plus 5 times negative sine is negative 5 sine x. And notice I have a negative exponent. So I'm going to rewrite. Since I have this negative exponent of -1/2. So it's going to be f prime of x equal to 3 over x to the 1/2, and then minus 5 sine x. Now the book goes further. Since we know the 1/2, x to the 1/2 is the same thing as the square root of x, this is really 3 over the square root of x minus 5 sine x. Again, so we just rewrite the x to the 1/2 as square root of x, since we know the rule for radicand signs, like if you have the nth root of x, that's x to the 1 over n. So they just kind of go in the reverse direction. All right, so that's those examples. And these dealt with finding the derivative function. Now, recall that the derivative function can give you the slope of the tangent line. For any point. All right, so for the following, you're going to find the slope of the tangent line for the given point. So it's number 31. So the function is f of x equal to 8 over x squared. The given point is 2, 2. So we're trying to find the slope of the tangent line, the line that touches this function or this curve at the point 2, 2. So since I know that the slope of the tangent line is given by the derivative, I would find the derivative, f prime of x. And then after I find the derivative, you obtain the slope, m, by plugging in the x coordinate of the given point. All right, that's how I'm going to approach the problem. So to do the problem, notice I have x squared in the denominator, so I'm going to rewrite it so that it's f of x is equal to 8 times x to the -2. All right, so that way I can apply the power rule. So for the power rule, so the derivative f prime of x will be, and I factor out the 8 times, and then you drop down the -2, so you get 2x to the -2 minus 1 using the power rule. So then f prime of x, 8 times -2, it's -16. And then x to the -3rd. And then I'll rewrite it so that it doesn't have a negative exponent. So f prime of x, -16 divided by x cubed. All right, this is the derivative function. So this is what we were doing in this previous example, finding the derivative. So that's what this is. Now to find the slope, the given point is 2, 2. But the x coordinate is 2. It just happens that the y coordinate's 2 based on the function. We only have variable x in our derivative, so we only focus on plugging in the x value. So I'm going to use x equals 2 since that's the x coordinate of the given point. So the slope m is equal to f prime and then 2. And then I plug 2 in for x, so it'd be -16 over 2 cubed. That's -16, and then 2 cubed is 8. So -16 over 8 is -2. All right, so the slope of the tangent line is -2. All right, and then I'll do another example where you find the slope of the tangent line. And this another example is number 37. So same idea. It's a different function. So say the function I give you is f and then theta equal to 4 sine theta minus theta, and the given point is 0, 0. So I'm going to find the slope of the tangent line. All right, and basically it's broken up into 2 steps. I find the derivative, so that's the first thing I do. Step 1 is find f prime of theta, and the second step is to find the slope m, which is equal to f prime, and you plug in the x coordinate, or the sort of our functions dealing with theta in the place for x. So really theta is 0. And both coordinates are 0 anyway, so I use the first coordinate. So you just plug 0 into the derivative function that you found from step 1. Now we have sine, and the derivative of sine is cosine. So derivative of sine, that's one of our rules. So sine of x is cosine x, and the other term is just theta, and that's like, think of that as just x, and derivative of just x, and it's just the variable by itself with an exponent of 1, the derivative becomes 1. So for this example, f prime of theta So the 4 you factor out and focus on sine theta. Derivative of sine is cosine. So this will be 4 cosine theta. Derivative of theta is 1, right? Because that's the same as like if we had the derivative of x, it's just a different variable. Now that's the derivative. Now I find the slope. And again, the point of 0, 0, you plug in the first coordinate. It happens to be that both of them are 0 based on our function, but you plug in the first coordinate, theta equals 0. So m equals f prime of 0, which equals, and I plug it into this, 4 cosine of 0. And then I have minus 1. And then on the unit circle at 0, cosine is 1. So this would be 4 times 1 minus 1. So 4 minus 1, which is 3. So the slope of the tangent line is 3. All right, so these two examples dealt with finding the slope of the tangent line. Now, what if they asked you to actually find the equation of the tangent line? So that's what these next couple examples are going to be. So for the following, you're going to find the equation itself of the tangent line. And this one's number 55 in the textbook. So the function is negative 2x to the fourth plus 5x squared, then minus 3. And the point in which we're finding the tangent line where it touches the curve at the single point is 1, 0. So the logic for this, it's going to be how we did the previous ones. We had to find the slope. So the first step we did was find the derivative. All right, then the second step we did was finding the slope. And the slope is m equals f prime. So you plug in the x coordinate or the first coordinate of the given point. And in this case, x is 1. So we're going to plug in f prime of 1 to get the slope. And now we just have this added step. And the third step is to just form the equation of the tangent line. All right, so that's the procedure that's going to be done. So first thing I need to do is find the derivative. All right, so f prime of x. So the first term's negative 2x to the fourth power. I factor out the negative 2, and then focusing on x to the 4, I apply the power rule. So I drop down the 4, so 4x to the, and then subtract 1 to the exponent of 4 minus 1 power. All right, that takes care of the first term. Second term, I factor out to 5. And then focusing on x squared, I'd use the power rule. That'll be 2 times x, or 2 minus 1. The last term is minus 3, and that's just a constant. and a constant turns into 0 when you take its derivative. So really that's plus 0 at the end. All right, so going about simplifying, f prime of x, -2 times 4, -8, and then x to the third power, and then 5 times 2 is 10, so plus 10, and then x, since that's 2 minus 1. All right, that's the derivative. So I need to find the slope. And the given point was 1, 0. So I find the slope m by plugging in the x-coordinate of the given point, and the x-coordinate's 1. All right, so I use the x-coordinate because my function derivative only involves the variable x. So instead of -8x cubed, it's going to be -8 times 1 cubed, and then plus 10 times 1. 1 to any power is just 1, so this is just -8 times 1, and that's going to be -8, and then plus 10. So you get this to be 2. So the slope of the tangent line is 2. All right, now I got to find the equation. All right, and you could do this two ways. The quickest way is to use point slope form. So it's quickest or quicker to find point slope form. Why it's quicker is because they give you a point and you just plug the coordinates into the formula for point slope form. And that's y minus y1 equals m times x minus x1 is the point slope form of a line. So we have m is 2. Our point, which we're finding the tangent line that it's going to touch the curve at, is the given point 1, 0. And we just plug in 1 for x1, 0 for y1. So really, if I plug those in, that's going to be y minus 0, which is just y, and then equals 2 times parentheses x minus x1, that'd be x minus 1. All right, and that is the tangent line. You could put it in point or slope intercept form, and that would be 2x minus 2. All right, and that's the form we're most familiar with, y equals mx plus b. So any form between the point slope form, slope intercept form are fine. You could also put it in the general form, but I don't see why it would just be more steps to do that. All right, so I'm going to do one more like this where I'm finding the tangent line. And this will be the last example for this section. So this is number 57. And the given function is 2 over the 4th root of x cubed, and the point that we're finding the tangent line at is 1, 2. All right, so again, I'm going to find the derivative. After I find the derivative, I can get the slope. And then after I have the slope, I can form the equation itself of the tangent line. Now the fourth root of x cubed you'd have to know from algebra. So I know I had a rule where it was the nth root of x equals x to the 1 divided by n. Now this is just if you have x underneath the radicand sign. Here we have x cubed. Now in general, if you have the nth root of x to the m, where x has an exponent, that's equal to x to the m divided by n. So for this one, I have the fourth root of x cubed. That's equal to x to the 3/4. Whatever the exponent is underneath the radicand sign, that goes up top for the fraction, and then the index goes on the bottom. All right, so that's really x to the 3/4. F of x equal to 2. Instead of fourth root of x cubed, I rewrote it now into x to the 3/4. Now I still need to rewrite it so that I don't have x in the denominator. And since it's in the denominator, I use the rule where negative exponent rule. So it's going to be 2 times x to the negative 3/4. So that way I can apply the power rule. Now for the power rule, the f prime of x times, and then I factor out the 2, and then focusing on the x to the negative 3/4, you drop down the exponent. This would be negative 3/4 times x to the negative 3/4, and then minus 1. All right, that's using the power rule. All right, so I just go about simplifying it. So f prime of x equals, and I can cancel out 2 from 4 to make this negative 3/2. That's negative 3/2. And then x. And then negative 3/4 minus 1, it turns into negative 7/4. All right, and I would go ahead and just make this a positive exponent. So by rewriting it, so it becomes negative 3, and then on the denominator, so we have 2 from the 3/2, and then we 2, and then x to the 7/4 power. All right, that is the derivative. So now I find the slope. All right, and the point that we're given in the question is 1, 2. So I only focus on the x coordinate since the function itself only has x. So I'm going to find m is equal to f prime of 1, just plugging in the x coordinate 1. So that's going to equal negative 3 divided by 2 times 1 to the 7/4. Well, 1 raised to any exponent is 1, so that's really 2 times 1 on the bottom. So I'd have 2 times 1 is 2, so that's negative 3/2. So the slope of the tangent line is negative 3/2. So I'm pretty much there. I just need to find the equation of the tangent line. So I know I have a given point, and then I have this slope. I'm going to use point slope form because that's quicker. Point slope form is y minus y1 equals m times x minus x1. And so I just plug in the coordinates of the given point for x1, y1. And so it's going to be y minus 2. since that's the y coordinate of the given point, equals -3/2. And then parentheses x minus the x coordinate of the given point, x minus 1. All right, and that's it. That's the tangent line. All right, and that's point slope form. If you were to convert that into slope intercept form, which I would accept as an answer, it would turn into y equals -3/2 x plus 7/2. So whichever of these two you want is fine. So here I'm already done with the point slope form. You can convert it into this slope intercept form if you want. All right, and that pretty much concludes the section. So the first several examples dealt with just applying the derivative rules. That was these ones that I was doing in the beginning of the video. And then after I did those, the next two examples dealt with finding the slope of a tangent line. And the derivative function gives you the slope of the tangent line. You just got to plug in the x coordinate for the point. All right, that was these two examples. And then this last two examples dealt with finding the equation of the tangent line itself, which basically you would have to find the derivative, then you'd find the slope, and you find the slope like plugging in the x coordinate of the point into the derivative. And then the last thing is to form the equation of the tangent line itself. And I pretty much go with point slope form since that's quicker. All right, and so next section is 2.3, and it's going to deal with more derivative rules.